Now that we have graphs of equations and graphs of functions, we can find their domains and ranges, maybe even more easily than we could with the algebra. The algebra was very useful to find domains. Range is super hard to find, at least for me, based on the algebra. Okay, so let's see if we can find the domains and ranges for each of these. Again, domain would be all possible inputs, which, since these are all functions of x, would be all the x values, and the range would be the set of all outputs, again, which are y values in this case. Okay, so domain. Okay, I'm looking at f. This is the graph of the function. And okay, when you get a graph, it's really bad about putting arrows on the end, but it would continue. And it's also really bad about labeling axes. Man, oh man. Okay, we need to teach the creators of the graphing software a thing or two. Okay, x and y. Okay, there we go. So we're looking at this thing. We want to know what the domain is. What are all possible inputs that give us an output, right? Everything? Yeah, actually, it is all real numbers. So minus infinity to infinity, or again, if you like that double bar R, you can use that. But we can put in any x and get out a y value, okay? Now, when we look at range, this is why a graph is super helpful, because I can say, okay, well, I can put in any x, and like the y's are going to be like above the x-axis, right? So like I put in 4, I get this. I put in 5, I get this. I put in 6, I get that. 2, I get that, right? So like, okay, this is fine. But what's the minimum that you can get for a y value? Well, it looks like its minimum is right here at 0, and it would be inclusive, and then it would extend up forever. So I'm looking at the y values. Again, y values, this would be your negative, and this would be your positive. And with intervals, we always start with the negative and work towards the positive. So whereas x, to look at domain strictly speaking, we begin at the negative on the left and work towards the right. With domain, we have to look, or with range rather, we have to look from bottom to top. Okay. All right. So g of x, domain, range. Okay. Here we go. We could find it algebraically for sure, but I want to try and do this graphically. Domain. Let's see. I'm looking at all the x's, and again, graphing software doesn't indicate that it continues on. And we label axes, but that's besides the point. What are the set of all possible inputs? I want you to take a guess and write it down. Answer, minus infinity to positive 1 inclusive. Okay, so the inclusive bit, it doesn't show it, but we would have a dot there, and you can verify it with your equation, right? You can stick in 1 for x and get out a value. Square root of 0 is just 0. Okay, and then the x values would just continue going left. But again, with interval notation, you start left and work right for domain. Okay, oops. And then for range, we are working with y's. So again, we start with the minus and work towards the positive. Okay, so in the minus direction, how far do I go? Yeah, based on the graph, you might say -2, right? But actually, this would continue down. It's just going down very slowly as we go to the left. So actually, the range here would be minus infinity, again, for the y's, because it would go down very slowly. And then, so that would be the bottom, and then all the way up top, it would go to positive 1. Okay? Because again, it would go from here up to here and stop. Okay? So that's the domain and range for those, okay? So domain and range of a function can be found. It's going to take some practice identifying these. We don't necessarily have to have a function to find the domain and range though, right? We talked about domain and range for a relation, okay? So if we're given any graph of an equation, we can find the domain and range, okay? So domain, range. Domain is a set of all possible x values, right? So possible x values here are -1 to 1, okay? x is going left to right. Okay, furthest left I can go is 1. And you might need to look at the scale here. It's 2 ticks, but every 4 ticks is -2. So that's -1, and this would be +1, and this would be +1, and that'd be -1. Okay, range y values looking from the bottom to the top, and so the furthest down I go is -1, and the furthest up I go is +1, and those are included. Okay, domain and range for those are both -1 to 1. Okay, and last but certainly not least, the volume of Descartes, domain, range. Domain is going to be let's see, how far does x go left? It goes off to -infinity. And how far right does it go? -infinity, or positive infinity as well. Okay, range here, again, going furthest down is -infinity. How far does it go up? Well, it just keeps on going as I go to the left, right? So positive infinity. Okay, looking at all the y values. So you could imagine if range is a difficult thing for you to see, imagine moving horizontal lines upwards. How far upwards can you go and still strike the function? Okay. Last one, and these are sort of my favorites to work with. So we want to identify the domain and range for the function below. This is a piecewise function, a little bit difficult to work with sometimes, but the domain and range here are going to be very interesting. So domain, again, is all the x values. Okay, how far left do I go? And then I want to think, okay, I want to continue to progress right. Where do I stop? Where do I have to exclude values? So as I go from the left side of the graph, I actually have the ability to extend forever to the left because of that arrow. Okay, so from -infinity, and then I get to 0 and I encounter an open dot. Okay, I have an open dot, but if I look a little bit further down, I notice that there's a closed dot. Okay, a closed dot supersedes an open dot. Okay, so that, and a closed dot means we have the value. So if we have the value, that supersedes not having the value. So normally I would say, okay, we have to stop at 0 and then begin at 0, but I actually have this value, so I can just keep on going. I can actually just keep going, and I would have x values all the way to +2. And then at +2, I have 2 open holes. Okay, meaning the value is absent everywhere. So I do not have the x value of 2, but then I go immediately to the right of the upper hole here, and I would have a value right after 2, so pretty close to 2, just not 2, and then I would continue going right forever. For the range, okay, this one could be a little tricky, okay, because we have to introduce notation we haven't used before. Range is a set of all y values, okay, so I start by looking at how far down I go. Okay, well, I don't have anything at 5, and then I'm going upwards. I have -4, okay, and that would be this horizontal green line, okay, but I don't have anything on either side of 4. So what we call 4 would be a singleton. It's just a single number, single observation of the variable y. So I have the y value of 4. I don't have anything around it. So I can't use parentheses or brackets. I can't use an interval, right? So, but I have more y values, right? So after 4, I would continue on. So I have to union this with, and then the next y value I would have would be at 0. And there's not a dot there, but if there isn't like an open dot or closed dot, always assume that it's a closed dot. So we have a value of 0. And then I'm going to continue moving horizontal lines up for y. Okay, I have this issue here at 1. okay? At 1, I have an open dot, but I have just the line over here. The line indicates a closed dot again. So I would just continue on. And I have a function value, function value, function value, function value, and same sort of thing here. And I can keep going up without stopping, okay? So I can extend the y values all the way to infinity, all right? So couple takeaways here. We have that singleton set, and then there are instances where we have an open dot without a closed dot specified. Assume that there's always a closed dot, and then continue on and make sure to use interval notation with unions as needed.